14 we will need forecasting PowerPoint and exercises. Okay, on chapter 14, the concept. Forecast is a prediction of future events used for planning purposes. Forecasts are critical input to business plan, annual plan, and budget. Organizations may use forecasts in many part of organization in many ways. Example, supply chain managers may use forecasts to plan for output level, purchases of services or material, workforce and output schedule, inventory, long-term capacity. Forecasts are made on many different variables, but all forecasts must share the same thing. All forecasts must have error. So good forecaster not only find a better forecast, but also find a better way to deal with forecast error. First concept we are going to study before picking the right forecasting tools is to find out what type of pattern of the demand we are facing. A time series is the repeated observation of demand for a service or a product in the demand occurrence. There are 5 basic time series. First, horizontal demand represent horizontal line of demand throughout the time horizon. When the demand is up or down gradually, we call trend demand. When the demand is up and down during at a period of 1 year, like this picture, we call this type of demand a seasonal pattern, which in this picture show the demand is low during month April and high during some September and October. When the demand is gradual increase or decrease for the overextended period of time, more than 1 year, we call this type of demand cyclical pattern. There are main keys to decision when we choose a forecasting technique. There are several key decisions when we make decision regarding forecasting technique. We may use judgmental method with regarding to qualitative method. We can also use causal method when two variables are related with each other. Independent demand is used to forecast dependent demand. We can also use information in the past to forecast the future demand using time series analysis. We also use trend projection using some type of regression analysis too. Forecast error. Forecast error is simply the difference found by subtracting the forecast from the actual demand. Forecast error, we use ET represent forecast error equal DT minus FT. DT represent actual in period T. FT represent forecast for period T. There are many forecast error indexes that we use to evaluate the forecast. First, CFE represent cumulative forecast error, which is sum of forecast error, ET. Average forecast error is an average cumulative forecast error. Mean square error equals sum of ET square divided by n. Standard deviation, mean absolute deviation, equals sum of absolute error divided by n. Mean absolute percent error equal mean absolute percent error divided by n. Or okay, with this example, we're gonna experiment on this example. First, we start out with example 1. Over here, students are encouraged to follow example. Okay, I'll enlarge them a bit. First, forecast error is the difference between DT minus FT, or demand minus forecast. Okay. When we add forecast error together, we call that CFE, or cumulative forecast error. Okay. When we average forecast, okay, average forecast error equal sum of forecast error divided by total number of data, which is 8 months. Okay, average forecast error, or E bar we call it. Sometimes we use a term called E bar. Okay, next we are going to find square ET square. So we use hat to represent square, hat 2. We add total E square together. Okay, then we find out the average by taking ET square divided by n number of sample, 8. We call that mean absolute error, or MSE. Next, we're gonna use function ABS to represent absolute, then take an error value. So we turn all the error value into an absolute value. Then we sum it, become total absolute value. Then we take that amount divided by total number of data, which is 8 months. We call that MAD, mean absolute deviation. Last, we take absolute value divided by demand DT times 100. We call that absolute percent error. So each of them represent percent error. We add them up, become total sum of error percent. Let me know. Okay, then we take the number divided by 8 to take an average. We call that mean absolute percent error, or MAPE. Okay, so this is called forecast error indexes. Okay, we can also find out how to find the standard deviation. Standard deviation equivalent to, okay, let's review the formula again. Standard deviation equal square root of sum of et minus e bar square divided by n minus 1. So we are going to first find et minus e bar for each column and then square it and then add it together and then divide it by n. First, we're going to find et minus e bar and all together square it. So first we are going to pick up et for each, okay, minus e bar, which is over here. We're going to freeze function 4 to refrain the position of e bar, and then you square it. Okay, so et minus e bar, okay, et minus e bar, and then you all together square. Okay, next we are going to sum this. Okay, once we sum it, then we're gonna find standard deviation by take square root of sum of et minus e bar square divided by n minus 1. Okay, n minus 1 is 8 minus 1 is 7. Okay, we will find out that standard deviation is 27.38. Okay, don't forget to save it. There are 14 exercises. Okay, now let's go back to the slide. So I hope students followed example and compare the outcome with the slide or my exercises. Okay, and there are a few ways to forecast using adjustment method. The first adjustment method we call sales force estimate. Second one, executive opinion, market research, and Delphi method. Sales force estimate is the method to use sales opinion or sales experience to forecast for future demand. Market research, on the other hand, the company may construct marketing survey to extract information from customer. A Delphi method is a method when you put together a group of panel anonymously. Everyone can provide an input. Then organization may extract information as a consensus to suggest for future demand. All together we call qualitative method, because all this method has nothing to do with quantitative or number. Next method we call time series method. Time series method is a quantitative method using historical data in order to forecast for future. We will use three forecasting methods: simple moving average, weighted moving average, and exponential smoothing. But first we call simple moving average. Simple moving average, in order to forecast into the future t plus 1, we will use the last n demand divided by n. Okay. So we are going to experiment on example number 2, but we are going to do 3-week moving average and 9-week moving average. Okay. In order to find 3-week moving average forecast, we are going to use at least 3 periods in the past in order to forecast in the future. So the first forecast is going to be for period 4, which equal average of the last 3 periods. We can say that forecast for period 4 equal sum of the last 3 periods divided by 3. Okay, when we drag it down, the next forecast will grab the last 3, which is period 2, 3, 4, become forecast for 5. That's why we call it moving average, because it's always moving. In order to forecast for 9-week moving average, we are going to go back for 9 weeks to forecast for 10. So we're going to use the average function. Go back for 9 weeks. We can say that forecast for week 10 equal 1366, which come from the last 9-week average. Moving forward for the next month, next forecast. Okay, that we call moving average, simple moving average. Okay, next we are going to find a weighted moving average. Students also have more example on the slide to review. Weighted moving average is different from simple moving average. Weighted moving average, we are going to assign weight for the historical demand. All the weight must add up to 1. By assigning weight, we will give more weight to an information that must closer to the forecast. Okay, by using this method, we example the forecast is for period 5. Period 4 we will give a higher weight because period 4 is much closer to period 5. We give higher weight of 0.5. 0.3 is given to period 3, which is 2 periods apart from period 5. And 0.2 is given to period 2 because it is the furthest period. All weight must add up to 1. With this example, we will maybe experiment on example 3. We're going to use weighted moving average. On example 3, the higher weight will be given to 0.5, second higher 0.3, and the last is 0.2. Okay, so we we are going to do 3-week period moving average. So the first forecast will be forecast for period 4 equal 0.5 times period that closer plus 0.3 times second closer plus 0.2 times the furthest, and then you can move it down like that. Okay, so we call this weighted moving average. Next forecast we call exponential smoothing. Exponential smoothing is sophisticated compared to simple moving and weighted moving average. It requires only 3 items of data: the last period's forecast, the demand of this period, and the smoothing parameter we call an alpha, where alpha is the number between 0 to 1. To forecast using exponential smoothing, we have 2 formula which will provide equivalent result. First, we can use the first one is the one I prefer, which is forecast for the future period equal alpha dt plus 1 minus alpha ft. We will use this example. We will use example number 4 to experiment on this exponential smoothing. Okay, example 4, we're gonna use the last 3 period as the forecast for 4, and then with the forecast for 4 we will use an actual of 415 and alpha 0.1 to forecast for 5. Okay, now let me increase. So we're gonna forecast for 4. We are going to use the last 3 week average. Okay, that is forecast for 4, and week 4 has actual demand of 415. Okay, and alpha .1. So forecast for 5 will equal, okay, alpha 0.1 times dt, because d4 plus 1 minus alpha times forecast 4. Okay, 398 is forecast for 5, or sometimes we denote like something like that, so we know trying to find forecast for 4. We call this exponential smoothing method. Okay, on example number 5, okay, is another example of the exponential smoothing. The alpha is 0.2. Their forecast for July 3rd is 24 to start with. Okay, July 3rd, the forecast to start with is 24, and alpha equal 0.2. Okay, Question asked you for forecast for August 7. First, we're going to find out forecast for July 10 equal alpha 0.2 times D3 July 3rd plus 1 minus alpha 0.2 times last forecast, which is 24. If we set up correctly, okay, you should be able to find out that. Okay, you can see that the forecast always grab the last period information. See, so for to answer the question, forecast for August 7 is about 26.4. So that's another exponential smoothing. Okay, so that the three type of example, three type of forecast that we're gonna study in this class, and we have one more example, which is example 6, which is a mixed example. We are interested to find out moving average. Okay, and the real demand of month 5 is 805. And we also interested to find weighted moving average 0.5, 0.3, 0.2. We also interested to find exponential smoothing with the starting week 4 forecast 784 with alpha 0.2. So first we're gonna use 805 to plug it in. Okay, so we have week 5 for 805. Okay, we want to find first 3-month moving average. And we have 3-month weighted moving average. And then with the last one we have exponential smoothing. And we have alpha 0.2. Okay, let me confirm it. Alpha 0.2, which F4 784. F4 783. First we're gonna find forecast for 5, and then find forecast for 6. Forecast for 5, it's gonna be the average of the last 3. Okay, and forecast for 6 will be the average of the last 3. forecast for 5 will be average of 4, 3, 2. Forecast for 6 will be average of 5, 4, 3. For weighted moving average, we're gonna choose 0.3, 0.2, and 0.5, 0.3, 0.2. So we're gonna go ahead and grab period 4 times 0.5 plus period 3 times 0.3 plus period 2 times 0.2. Remember, the closer, the higher the weight. 1, 2, 3. Okay, we can write it down. We should be able to grab the right information. Okay, next we are going to do exponential smoothing by use F4 as 784. So in order to forecast for 5, we can take a demand of 4. First, to take alpha 0.2 first times D4 plus 1 minus alpha times A4. Okay, and then we drag it down. Should be able to fill in all those information. Okay, I think that that's all information that needed. Format a little bit. Okay, so I hope that when students are comfortable with all these exercises, students should also, I encourage that students use Excel to complete this homework. Thank you very much.